moving on to the slide 9. So in this slide, I will be discussing about how the Austin Animal Shelter dataset pre-processing has been handled. So initially, we found there are missing values in the variables sex upon outcome, age upon outcome, and the outcome type. So the missing values of sex upon outcome has been replaced by unknown. The missing values of age upon outcome has been replaced by median of the column, and the outcome type is null in the 7 values identified. So the rows have been removed. Coming to the age transformation. So the age transformation attribute values are converted to months by using the Python code to maintain the consistent numeric representation across all the records. And the third part of pre-processing including removing the irrelevant attributes. The attributes such as animal ID, date and time, and date of birth are dropped since these attributes are irrelevant for the model processing. So after this pre-processing of the Austin Animal Shelter dataset, I have been saved a copy of cleaned dataset and submitted along with the project report. Moving on to the supervised machine learning algorithm, which is a regression algorithm I included in the coming slides onwards. So here I chose Abalone dataset for doing this regression algorithm. So Abalone dataset also have some pre-processing steps include, which is shown here. The Abalone dataset is having the categorical variable of sex and numerical predictors of length, diameter, height, hole height, shunt weight, the weight, and shell weight. So here the target variable is identified as age, which is rings plus 1.5. So the pre-processing steps which we did before modeling includes converting the target column as age, which is equal to rings column plus 1.5, and then the categorical variable has been one hot encoded to convert them so that we can make sure it will be ready for the model processing. And then the third part is we check the missing values in the dataset and handled. The last part, we don't need feature scaling for this model because I have chosen the random forest, which is a tree-based algorithm. So why we have chosen the random forest algorithm is basically the random forest algorithm can handle non-linearity. Since Abalone age does not increase linearly with size, random forest captures the complex patterns. Also, the dataset is having mixed feature types. So random forest works well with both numerical variables and also one-hot encoded categorical variables. Random forest also will reduce the overfitting problem, and it has a very strong real-world performance. So that is why the random forest algorithm has been chosen. And moving on to the next slide, which talks about how the model has been implemented. So under model configuration, we have chosen for 300 trees to train, and the data has been split 80% of training and 20% of testing dataset. We chosen the random state as 42, and the model has been validated using tenfold cross-validation method. So after implementing the random forest algorithm, these are the metrics we have achieved, stating as R square as 0.54 and MAE as 1.58, RMSE of 2.24. So the R square 0.54, it explains the 50%, 54% of the age variation after we predict the age of the abalones, and MAE of 1.58, which is an average prediction error close to 1.6 years, and we also got MSE of 4.706 out of our tenfold cross validation. So The conclusion of random forest algorithm is it has a very strong practical performance biological age prediction despite of the mixed data which is having both categorical and numerical. With this, we can conclude, the random forest is a strong model to predict the age of the abelons.